Hello and welcome. It's February 14th, 2026, and while the world may be preoccupied with other events, something monumental has just occurred 180 million kilometers from Earth in the deep vacuum of space. Imagine the calm, reliable needle of a compass, pointing north, steady, dependable. Now picture that needle violently swinging back and forth from south to north, then back again 7 times in less than 4 hours. On Earth, a magnetic reversal takes 200,000 years, but something just did it in 240 minutes. At 8:15 UTC today, NASA's Deep Space Network cross-referenced data from the Parker Solar Probe's magnetometers and detected an unexpected magnetic surge coming from the object we call 3I, Atlas. This wasn't just a static magnetic field. What they saw was a dynamic, oscillating polarity shift. The reading confirmed a field strength of 400 nanoteslas. To grasp the magnitude of this, let's put it into context. Comets, by definition, are icy bodies, dirty snowballs, really composed of dust, ice, and rock. They are magnetically inert. Comets don't have molten iron cores like Earth does, which generate magnetic fields. So why would an object 180 million kilometers away be generating such a field, let alone one that changes polarity at such an extraordinary rate? This should not be possible. It defies the basic principles of astrophysics that we understand about comets. When the first signal hit the sensors at Goldstone Observatory in California, the technicians assumed it was a glitch, a sensor error. But 90 minutes later, the signal came again. The polarity flipped north, became south, and then again and again. NASA quickly took notice, but they weren't the only ones. The European Space Agency's ground station in Malargüe, Argentina, confirmed the same unusual fluctuation. Japan's JAXA Yoshida Deep Space Center also independently verified the signal. 3 continents, 3 space agencies, 1 impossible conclusion. 3I, Atlas is generating a magnetic field that is active, oscillating, and cannot be explained by any known models of cometary physics. At this point, you would expect a rock tumbling through space, but when you look at the raw data, it's not a mess of chaotic noise. It's a perfect, sharp, square wave. Up, down, up, down. These weren't random fluctuations. These were precise intervals, and that's where the mystery deepens. Astrophysicists, with all their expertise, are still left asking, what is generating the power to flip a magnetic field of that intensity? A dead rock can't do that. It needs energy, massive amounts of energy. So the question looms large. Are we fundamentally wrong in our understanding of comets, or is 3I Atlas not a comet at all? The data, as strange as it may seem, points to something even more unsettling. The more we look, the more the pattern emerges. Magnetic fluctuations from a comet, let alone with such precision, are unheard of. Normally, comets are chaotic, tumbling with erratic magnetic behavior. But the data doesn't fit that narrative. Instead, we're seeing an ordered pattern. The question is, what's causing this? And if 3I, Atlas, isn't a comet, what is it? Keep watching, because the next few hours are crucial in answering that question. Let's take a closer look at the timeline because the sequence is the key. Event 1 occurred at precisely 8:15 UTC when the magnetic north pole of 3I, Atlas, snapped into alignment. It held steady for exactly 1,340 seconds. Event 2 came at 8:37 UTC, and that's when things took a violent turn. The polarity flipped 180 degrees, heading south, and held for another 1,340 seconds. Event 3 at 8:59 UTC saw the pole snap back to north, maintaining the same 1,340-second duration. This wasn't random, folks. This was highly precise. In astrophysics, this kind of behavior is known as a periodic oscillation. However, periodic oscillations usually happen over days or even years. But here, 3I Atlas was flipping like a metronome, maintaining the same timing to the second. This isn't the behavior of a comet tumbling in space. Now, picture the atmosphere at the European Space Agency's Operations Center in Darmstadt. At first, they thought it was just a sensor echo, a temporary glitch. But then came Event 4, which would change everything. At 9:21 UTC, the pattern changed. The duration didn't stay constant, it halved. The fourth reversal lasted exactly 670 seconds. The fifth reversal also lasted 670 seconds. The frequency was accelerating. At this point, the object wasn't just flipping, it was speeding up its magnetic cycle. Pause for a second and think about what that means. If you spin a top, it wobbles and slows down due to friction or outgassing. It doesn't double its speed suddenly. That would violate the laws of physics. But the data from the Parker Solar Probe didn't show a slowing object. It showed an accelerating one. This wasn't just a cosmic anomaly. It was a puzzle that even the most experienced scientists struggled to solve. By the time Event 6 occurred at 9:43 UTC, every space agency was on high alert. The Goldstone antenna in California, the Canberra station in Australia, and the Madrid station in Spain all saw the same thing: a massive spike in magnetic field strength, jumping from 400 nanoteslas to 950 nanoteslas, followed by another reversal to south. But that was just a precursor to what came next. Event 7, at 10:05 UTC, broke all conventional understanding. The seventh reversal wasn't like the others. This time, the polarity didn't flip back and forth. It locked. For the first time, 3I Atlas stabilized in a rigid, high-intensity northern polarity. It was as if the object's engine was revving up and now idling. For the last 4 hours, it's maintained this lock with zero fluctuation. The physics of this are completely baffling. Now, picture this: a comet flipping its magnetic poles in precise intervals. Then, it starts accelerating its frequency. Finally, it locks into a stable high-energy state, unlike anything we've seen in cosmic history. This isn't just a cosmic anomaly. This is something far more complex, something that challenges everything we know about planetary science and astrophysics. In the coming hours, we might discover more about 3I Atlas than we ever thought possible. What's going on inside this object? What's the energy source behind these flips? The next piece of the puzzle may be closer than we think. Now let's take a deeper dive into what's happening inside 3I Atlas. This object is only about 2 kilometers wide, far too small to have a molten core capable of generating such a magnetic field. Comets, by their nature, are frozen solid, their temperatures sitting at around minus 140 degrees Celsius. By all known laws of thermodynamics, the inside of 3I Atlas should be static, completely frozen in time. Yet, the magnetic field detected is anything but static. The Parker Solar Probe recorded a field strength of 950 nanoteslas, nearly 1,000 times stronger than what we expect from a typical comet. And that raises the question, how is this even possible? We checked the solar wind data to rule out external influences. Perhaps the solar flare or coronal mass ejection could explain it. But the data from NASA's Space Weather Prediction Center shows calm solar conditions, no solar flares. No significant changes in the magnetic background. So, the magnetic field isn't coming from the Sun, it must be coming from 3I, Atlas itself. But if it's not a molten core or solar wind, then what could it be? The answer may lie in a material that behaves in an entirely different way, a superconductor. Superconductors have unique properties. They can trap and hold a magnetic field without any external power source. But here's the catch. Superconductors require extreme conditions or specific refined materials to work. You don't just find large deposits of superconducting alloys floating in space. The odds of 3I Atlas being made entirely of superconducting material are practically zero. So we must be dealing with something far more complex, something that doesn't fit into our current models of space objects. But it doesn't end there. We know that when a magnetic field flips, it exerts a torque on the object. It should affect its rotation. Yet, when the magnetic field of 3I Atlas flipped violently at 9:21 UTC, the Hubble Space Telescope tracked its light curve, and the data showed something shocking. The object's rotation didn't change at all, not even a fraction of a degree. Normally, a sudden flip in magnetic field would cause a comet's rotation to speed up or slow down due to the conservation of angular momentum. But 3I Atlas didn't respond to the magnetic torque in any observable way. It's as if the object's magnetic field is completely decoupled from its physical mass. This breaks the laws of motion as we understand them. Imagine being in a car and slamming on the brakes. You'd feel the force, right? Now imagine the car stops instantly, but you feel no force at all. That's what's happening here. 3I Atlas is experiencing a magnetic flip, but its rotation remains completely unaffected. This could mean that the object has an internal structure that is somehow able to manipulate electromagnetic fields independently of its physical rotation. But how and why? The implications of this are staggering. Now, let's talk about the chemistry. While magnetometers were recording these bizarre events, the James Webb Space Telescope was busy analyzing the composition of 3I Atlas. They expected to find water, carbon dioxide, or other typical cometary elements. Instead, what they found was something altogether unexpected, a spectral line that shouldn't be there. This rare, specific signature baffled the team. They recalibrated their instruments and checked again. The result was the same. A signature of an element that doesn't belong in a comet. This wasn't iron or ice. It was something far more unusual. Something that defies our understanding of planetary science. The signature detected was that of technetium, a rare element that doesn't occur naturally on Earth. In fact, it's typically only produced inside the cores of dying red giant stars or in nuclear reactors. The presence of technetium-99 on 3I Atlas raises serious questions. How did it get there? If it's not a naturally occurring substance, then where did it come from? The answer may hold the key to understanding the true nature of this object. The discovery of technetium-99 on 3I Atlas is one of the most bizarre findings in recent history. Technetium is not stable. Its isotopes decay quickly. If 3I Atlas were formed billions of years ago, as we once believed, the technetium should have decayed long ago. Yet it remains, implying that it was recently synthesized. But how could this happen in a frozen, distant comet? And if 3I Atlas isn't just a simple chunk of ice and dust, what is it? The discovery of technetium-99 is troubling because it suggests that this object may not be a comet at all. It could be something entirely different, something artificial. If 3I Atlas is not a comet, then the magnetic flips, the decoupled rotation, and the technetium signature are all part of a larger puzzle. A puzzle that's only beginning to unravel, but there's more to this mystery. What we know for sure is that 3I Atlas is emitting a magnetic field of unprecedented strength. And when you add the spectral signature of technetium-99 into the mix, the evidence begins to point toward an artificial origin. It's as if we're seeing the signals of a technology that's far beyond anything we've ever encountered. This is no longer just about comets or asteroids. This is about something far more complex, something that defies our understanding of space and science. As scientists and astrophysicists scramble to make sense of these findings, they are left with one crucial question. What is 3I Atlas really? Could it be the remnant of an ancient supernova? Or is it a piece of technology from an advanced civilization long lost in the vastness of space? The data we have so far suggests that the latter may be closer to the truth, but there's still so much we don't know. Every new piece of data raises more questions than answers. The magnetic flips, the acceleration, the decoupling of rotation, and now technetium, each discovery builds on the last, suggesting a pattern that could reveal something far more profound than a simple space rock. As the data continues to pour in, one thing is certain: we are on the verge of a discovery that will change everything. Now, let's talk about the energy source behind all of this. We know that 3I Atlas is generating a powerful magnetic field, but where is the energy coming from? If it's internal heat, the object should be glowing in the infrared spectrum, but it isn't. If it's propulsion, we should see a change in its orbit, but we don't. The object is not moving in a way that suggests propulsion. So where is the energy going? This question is critical. It's the key to understanding what 3I Atlas really is. If it's not heat and it's not propulsion, then what is it? The answer could be hiding in plain sight. As the object approaches the asteroid belt, the gravitational interactions will test its stability. Will it remain stable, or will the forces at play send it spinning out of control? The telescopes are watching. The data is flowing in. We are about to find out. The magnetic pulses are continuing, and the deep space network is still tracking every signal. Every 670 seconds, the magnetic field spikes, but now it's no longer flipping. It's pulsing like a heartbeat. And that's when things start to get even more intriguing. Could this pulse be a signal? Could it be a message? Or could it be a sign that 3I Atlas is coming to life? As it crosses the threshold of the asteroid belt, the data will be scrutinized like never before. And whatever 3I Atlas truly is, we're about to uncover it. It's only a matter of time before the next breakthrough. The clock is ticking. The answer is within reach. Stay tuned, because in the coming hours, we will learn more about 3I Atlas than we ever thought possible. And now we find ourselves at a crossroads. The data continues to stream in, each piece bringing us closer to the truth. The magnetic pulses, the spectral lines, the rotation decoupling each of these observations points to something that doesn't belong in our solar system, something that is challenging every fundamental law of physics we've relied on for centuries. As the object nears the asteroid belt, the next phase of our investigation will begin. The gravitational interactions at this point will test the stability of 3I Atlas. Will the object continue its strange behavior, or will it finally reveal its true nature? The telescopes are ready, the detectors are live, the data stream is active, and the world is watching. For those of us in the scientific community, this moment is nothing short of a revolution. We're on the brink of uncovering something that will change our understanding of space, of physics, and of the universe itself. The question isn't just about what 3I Atlas is, it's about what it's doing and why it's doing it. As the hours pass, the mystery will deepen. But one thing is certain, the next few days will be crucial in solving this puzzle. 3. Atlas is not just an object in space. It's a key to unlocking a whole new chapter of cosmic exploration, and the truth is out there, waiting for us to discover it. Stay with us, because this is just the beginning. If you want to know what happens next, make sure to subscribe and hit the notification bell so you don't miss out on any updates. The universe is calling us, and we're just getting started.